Math Through the Ages, A Gentle History for Teachers and Others by William P. Burlinghoff and Fernando Q. Gavia? Gavia. Let us get this started with time for my highlight time. Today, we're just going to be talking about history and mathematics in a large nutshell. Then we'll be talking about these sketches, which I will split into these two parts, because they're like too big and I need to brush up on my math. Math is my favorite subject, even though I'm not the top of my class. Let us get this started with history of mathematics in a large nutshell. History, that's one thing I'm good at. Let's start off with the beginnings. We start off in the olden age. As in the olden age, I mean the caveman age. The times when they drew paintings like this, and they were like, "Look, make stick, make stick, make tally," that kind of thing. They started off with counting with, obviously, their fingers. What else did they have? They went ahead and represented 1 mark for 1, 2 marks for 2, 3 marks for 4, and so on. Problem is, this went on a little too long. Too much. And this was really inefficient. But the cavemen didn't exactly have another way to do this, so they went ahead and did this. Most of all, though, they mainly focused on the concepts of numbers, patterns, primarily in nature, magnitude, and the form, but the most simplest one have been shown as numbers. Obviously, back then, you didn't really need to know how many big numbers there are. All you needed was like 1 all the way to 10, and you could probably figure things out. Pretty sure the biggest number you'd ever use is something on the lines of like 50 or maybe 100, but that's still countable with your hands, I think. I mean, we found some bones which have some tick marks on them, which shows that they knew at least how to count. Eventually, that system evolved into the time mark system that we sometimes use today, because, well, writing 1, deleting it 2, deleting it 3, deleting it 4 is pretty inefficient, and especially if you're Chinese who write numbers like this, so that it's not going to be really efficient, don't you think? Yeah, this isn't exactly going to work. Others, even like the Egyptians, use this. This was a 3, this was a 5, this was a 6, this is a 9, and as soon as it becomes a 10, we replace that with this, and I'm pretty sure you can figure that rest out. This is 100. This is apparently 100, and this is apparently 200. I have no idea what 1,000 is. This is apparently 1,000. This is apparently 10,000. So if you're like, write 40,000. 40,600, 206. Let's try to write this in, let's say, numerals. Well, then you're gonna end up with something like this. Let's see, 6, no, 10s. I'm just gonna use this because it's way easier. 2 hundreds, 6 lotus flowers. I wish copy pasting was a thing. 6 lotus flowers. And then we have 4 pointing fingers. That's a really bad pointing finger. Yeah, this would be 46,206. Thing about all this is that it's pretty inefficient, and eventually we, for some reason, the Romans started using these Roman numerals. 1, 2, 3, 4, 5, 6. And then we have 9x, 100, 50. Yeah, I definitely messed up the Roman numerals. I never memorized the Roman numerals. And, that is one of the most inefficient writing systems ever. Like, try to multiply this with this by only using Roman numerals. This is definitely not going to exactly work out, don't you think? But for some reason, we started the entirety of Europe using Roman numerals because the Romans conquered pretty much most of Europe. So we were stuck with this system for a very long time. Now, while we're on the topic of the Romans, we should start talking about the Greeks. The Greeks themselves had their own golden age of mathematics, mainly because they had the greatest mathematicians ever. It is still a mystery if Pythagoras himself was really a mathematician. Also, we are pretty sure he wasn't the first one to go ahead and create the Pythagorean theorem, which is like a squared plus b squared plus c squared, which I'm pretty sure Technoblade is thankful for being a math nerd. He ain't a math nerd, he's a statistics nerd. According to Skeppy, Technoblade got a 5 on the AP Statistics test, which is really impressive. Always makes me wonder why he dropped out of college. Yes, regardless, let's go back. We go ahead and learn pretty much about the Greek mathematics. They themselves went ahead and created most of the mathematics that we know and love today. Mostly so, they focus on geometry, mostly this shape for some reason, the pentagram. This is called the pentagram. I could probably draw a better one. You know, the star that's on Captain America's shield. Except it's called a pentagram because there's a pentagon in the middle when you go ahead and you replace it with stars at the edges. This, for some reason, they went ahead and some of these Greeks worshipped it as a god. They worshipped the pentagram, which is highly ridiculous nowadays if you ask me, but unfortunately back then there wasn't exactly a wide range of Greek gods. The Romans literally copied the Greek gods. According to ancient Greek texts, the first Greek mathematicians were Thales. He himself lived around in 600 BC, and Pythagoras lived in 500 BC. Most people acknowledge Pythagoras as like the first Pythagorean, mainly because, well, Pythagoras, he was literally the one who founded the Society of Pythagoreans, but we highly doubt that he himself really participated in the Pythagorean Society, mainly because we pretty much think that he's not exactly much of a mathematician, even though most people attribute him to a squared plus b squared equals c squared, aka Pythagorean theorem. We highly doubt that he really first created the Pythagorean theorem because the Indians and the Hindus and the Egyptians all created tables that worked for that Pythagorean theorem. Like 3, 4, and 5, and 5, 12, and 13. Like, they literally had these tables with these right triangle measurements, and I kind of understand why. Building pyramids requires right triangles. And for some reason, that even includes measuring the shadows of these pyramids. So it's beyond me why you would want to learn the shadow of a pyramid. Oh, right, you want to find the height of the pyramid. Great. Now, I'll give you some proof of the Pythagorean theorem myself. Also, this is mostly history. I'll probably talk to you about it myself, too. One of the earliest proofs that we created, Einstein himself created with some of these theories, some of these proofs of the Pythagorean theorem, but I'm not going to go ahead and talk about Einstein's theorem. It's a little too problematic. Go ahead and you make this. You make 4 consecutive triangles. There. You make 4 equivalent, congruent triangles. I should probably try to make this more of a square. I'm not dealing with this. Let's go to the notes. First off, a square. You make a square. Then you go ahead and make this, where all these triangles are congruent. Set these sides as equal to A. Set this side is as equal to B, so that each side of the square, the big square, is A plus B. Then the inside is C. So we get this C squared. And so the area inside here is C squared, and the areas that I am now shading in red will be 1/2 of AB, because triangle theorems, you should learn this already if you're watching this channel. Then make 4 copies of the triangles. Arrange them like this. Fill in the parts. So this is A squared and this is B squared. Notice, that's the exact same space as this. C squared. Proving A squared plus B squared is equal to C squared. Some people say that Pythagoras himself has created this proof. I am the one to doubt because we have no idea. And we probably shouldn't exactly believe the records of those times because it's really ancient and they're really sparse. And they believed in mythological man horses, so you really shouldn't take their accountability. You should probably take their accountability to credit. But this is just one of those proofs that I really wanted to share to you while we're talking about history. Alright, we haven't even started. No, we haven't even went through the whole thing yet. Alright, then we have to talk about India. India itself is pretty important, and they themselves have created several important things as well. So one more thing I want to talk about the Greeks is how much they love circles. They really love circles. They were the ones who started calculating pi, and they just rounded it to 22 divided by 7. Which is, I suppose, accurate, but not exactly, to the point accurate. And they were the ones who decided to even think about arithmetically going ahead and figuring stuff out, figuring out the process. They were the ones who figured out how to write the process, and 5 to the half divided by half square would be 5 half times 5 half, and then they write that down, and then they'd be 25 divided by 4. Except they didn't use Arabic numbers at the time. The best they could do was probably something like this, except they didn't use English either. Meanwhile, in India, finally, we just arrived here. I'm probably gonna have to group all these together. I'm gonna have to speed this up. In India, though, they went ahead and for the next 400 years or so, the Europeans themselves and North Africa saw very little mathematical activity. well, yeah. The Roman Empire, barbarians, and the Eastern Roman Empire and those kind of stuff didn't exactly work out for the best, but the scholars of Byzantium were more interested in other things than, well, say, math. They preserved copies of the ancient mathematical manuscripts, but they didn't really show real interest in the content of all that stuff. Of course, during this period, people were still building, buying, selling, taxing, and surveying, so obviously math still was happening. While this was happening, they went ahead, the Indians at least, created several math. Lots and lots of math. They went ahead, created the half chord, the sinus. Still have yet to learn that kind of stuff. And they even created this little thing called the bowstring chord, because apparently this section looks like a bowstring. Can you see it? I'm not going to explain the math about this because unfortunately that will cost me lots of time, but all you need to know is that the Indians created this. Mostly though, they went ahead and made several contributions towards trigonometry. Trigonometry. And yeah, well, they also started working with circles, radiuses, because unfortunately decimals still didn't exist at the time. With really big radiuses. Like some guy named Aryabhata, I'm not even going to Google how to say that, went ahead and used a circle with a radius of 3, 4, 3, 8 to go ahead and construct a table of sines, because at the time we didn't have decimals, so, well, we needed a table of sines, cosines, and tangents. The Indians did that. Why the number 3, 4, 3, 8? Well, mainly because a circle with the circumference of 2,100 and 21,600, well, that would be equal to 1 minute. It's a clock, get it? Where they will go ahead and make 1 unit length of the arc, which is equal to 1 degree of the arc. Figure that part out in the next video. To be equal to 1 minute, 60 seconds. So 60 times 360 degrees, that will be equal to 21,600. Now, I promise you, I probably won't get into more math, but I will tell you more about math history. He went ahead and used those kinds of ratios so that he could probably use these ratios easier, and they were easier to implement because 360 and 60 pretty whole numbers. Why the number 360, you ask me? Because it's divisible, and what we know, a year lasts 365 days. Technically, it's 365.1 quarter days, which is why we have leap years. But, well, 360 itself is a rounded number, and it's really divisible too. You can divide it by 1, you can divide it by 2, you can divide it by 3, you can divide it by 4, you can even divide it by 5, 6, 7, no, not 7, unfortunately. You can divide it by 8, you can divide it by 9, 10, 12, and etc. And then we arrive to the Arabics. The Arabics themselves have went ahead, starting like in 750 AD, the Islamic Empire themselves have went ahead and expanded and stretched all the way from the western edge of India to parts of Spain. And they went ahead and wrote their own first scientific work, mostly science unfortunately, but they still invented algebra. They had the most important person in arguably all of mathematics ever. Algorithm, which might sound familiar because he's the inventor of the thing that we now know today as algebra. Some of us hate it, some of us love it. Like me, algebra is the easiest math I know. He himself started creating algebra, and he went ahead and made an important and crucial part of Arabic mathematics. So mathematics used on the foundations of the subject. In fact, algebra is known as the foundation of all of the advanced math that you'll know. Without algebra, algebra is the calculus of kindergarten math. Primary school math. Algebra is the calculus of primary school math. And then from middle school onwards, you're going to have to use algebra to, do stuff. Famously, you can go ahead and start writing equations too. Remember, the Arabics themselves, even though the Arabics didn't invent this number system, went ahead and used these number systems, which is really useful, but unfortunately they were banned because, you can write a 6, make the paper upside down, and you get a 9. You put in a 1, you add a 0, and, boom, you just created a 10. A 0 and you add a 9 in front of it and you just, increased it by 90. Yeah, this is why it was banned, but unfortunately it was so useful that we use it as the modern day symbol. Of course, our languages each have different ways to write our numbers. Like several nations use different ways to describe 1. But all of them, standardly, when writing it as numbers, we use this as our representation of 1. Or this. But I'm pretty sure you'd better use this, don't you? And it's made it easier to at least talk to other people and share stuff in math, because you can always read math and understand it. Even if you're from China and you just moved to America, the easiest subject for you would arguably be math. And then we go ahead and, well, talk about all this Arabic math. And the Arabics themselves, as I mentioned earlier, created that algebra stuff. And using that algebra, we went ahead and made it much, much simpler to go ahead and, like, write stuff and compare stuff and, just essentially do calculations. Like, instead of this, you get this, which is way easier to do. I'll just demonstrate to you right now. 4, 7, 32... And then you get 2,592. Like, you can already understand how algebra is really simple and makes things simple as well, too. And it's always about finding the unknown. You can always find the unknown if you like two unknowns, like x plus y is equal to 5. But you have two equations, like you also have 5 minus x is equal to, like, let's say 3. Then you can figure out what x is. Spoiler alert, y is equal to 4, x is equal to 1. Pause the video to try out these problems yourself. And they themselves have went ahead and added all those numbers as well too. This is around the time when the idea of negative numbers started coming in. I mean, back then all you needed was 0, 1, 2, 3, 4, and the only time you really used negative numbers was like when you owed someone money. Like if you owed someone like $2, then you'd have like negative $2. And if you owed someone like if you owed someone $100, that means you owe them like $100, so you had negative $100. Other than that, we never really used negative numbers, and we never really imagined that either as well too. But negative numbers themselves started becoming the norm because we finally found out that calculations such as x squared minus 4x minus 9 is way easier to do, or like definitely not this, but like some calculations were way easier to do if you could like use negative numbers. And this is when complex numbers and things will come in, but that's for the math videos. And just to wrap things up about the Arabic math, we're gonna have to go ahead and talk about Pascal's triangle. Like, before Pascal even existed, the Arabics themselves have went ahead and created the early parts of Pascal's triangle. They only knew, like, the first few rows, but other than that, they were all like, yeah, this is pointless. Like, let's say 1, 1, and then 2, 1, 1. So 3, 3, 1, 1. Like, you can already see the pattern, can you? You can already see the pattern. And they were able to do this. They invented Pascal's triangle way long before Pascal. But this worked out for them very well. And it's important to mention that mathematics itself was advancing. Along with mathematics, of course, it came with the inventions of the sciences, like medical stuff, the physical stuff, and the biology. Also, biology itself was still kind of new in the sense of a course. So was chemistry and physics. Back then they had alchemy. But next time we'll be starting with our topic, where discussion of the medieval Europe. I know this isn't Crash Course and you'd rather watch Crash Course than watch this 18-minute video, but I like math, so I really hope I made this video infectious. Until then, Shihana peace, bye bye.